what if I told you that in the span of a single human lifetime, we could make a barren, alien world feel more like home than Earth itself? What if, by 200 years from now, your great-grandchildren were walking on the shores of oceans we created, breathing air that didn't exist until we made it? Would it be a dream come true? Or a nightmare of our own making? But before you answer, consider this. Is it possible that we are already preparing to terraform ourselves? Before we can reshape other worlds, are we certain we even understand what makes this one so fragile? If we're to survive the journey to Proxima Centauri B, we must confront a deeper question. Can humanity escape not just the boundaries of space, but the boundaries of our own nature? Welcome to the 200-year journey to terraform Proxima Centauri B, a story of science, ambition, and the ultimate test of what it means to be human. In 2016, the discovery of Proxima Centauri B sparked the imagination of scientists and dreamers alike. Orbiting just 4.24 light-years away, this rocky exoplanet sits in its star's habitable zone, meaning, theoretically, liquid water could exist on its surface. And where there's water, well, there could be life, right? Or at least the possibility of life. But back then, as thrilling as it was, Proxima Centauri B was more of a distant idea. Sure, it was exciting to know a potentially habitable planet was sitting in our galactic neighborhood, but it was also completely unreachable with the technology we had at the time. The big questions loomed. Could we ever get there? Could we terraform a world like this and make it suitable for human life? In the early 21st century, the concept of terraforming was mostly confined to science fiction. The challenges? Enormous. There was the lack of a breathable atmosphere, temperatures that would freeze the blood in your veins, and solar flares from Proxima Centauri that could fry any unprotected life on the planet's surface. Some experts believed it was impossible. Others argued that with enough technological advancement, we could overcome these hurdles. Fast forward to the 2050s. Humanity's first step toward realizing the dream of interstellar exploration finally happened. Unmanned robotic probes were launched toward Proxima Centauri B. These probes, equipped with cutting-edge AI and advanced sensors, began the long journey across the void. Decades of waiting followed. But when those probes arrived, the data they sent back was nothing short of groundbreaking. The surface of Proxima Centauri B? Not exactly welcoming, a rocky, lifeless world bombarded by radiation with no real atmosphere to speak of. But that wasn't a deal-breaker. It was expected. What mattered was the wealth of information the probes gathered. Gravity levels, the composition of surface materials, clues about where water might be locked beneath the surface. All of this was the first critical step toward making this distant planet a candidate for terraforming. It was like looking at a blank canvas, full of potential. The question became, how do we begin painting the picture of a habitable world? And more importantly, how long would it take to transform this inhospitable landscape into something that future generations of humans could one day call home? By the late 21st century, humanity had already achieved remarkable feats. But the idea of traveling to another star system, that still seemed like a fantasy. For decades, scientists had been pushing the boundaries of propulsion technology, searching for ways to travel faster than light, or at least close to it. And while science fiction had toyed with the idea for years, the reality was much more complicated. Space, after all, is unimaginably vast. The distance to Proxima Centauri B, at over 4 light-years away, was staggering, unreachable with the technology we had in the early 2000s. But after decades of relentless research, failures, and breakthroughs, the impossible became possible. By the 2080s, humanity had cracked the code. Using a combination of near-light-speed travel and advancements in faster-than-light (FTL) technology, scientists finally developed a ship capable of crossing those light years in just 5 years. It wasn't true FTL in the sense of Star Trek's warp drives, but it was fast enough to make interstellar travel a reality. This ship wasn't just another spacecraft, it was a lifeboat. A vessel carrying humanity's brightest minds, scientists, engineers, visionaries, people handpicked to not only survive but to build something entirely new on Proxima Centauri B. Their mission? The first manned journey to another star system, and with it, the bold plan to terraform a barren world. the day finally arrived. The colony ship, named Pioneer, set out from Earth. With supplies and equipment to last a generation, the crew braced themselves for the long voyage through the cold expanse of space. For the first time, humans would travel beyond the solar system, beyond everything they had ever known, into the unknown. For 5 years they traveled. 5 years in the dark, between stars. Imagine that, 5 years of seeing no familiar sky, no sunrise or sunset, knowing that your destination was a world that had never seen human footsteps. And when they finally arrived, Proxima Centauri B was waiting for them, barren, hostile, and indifferent. The landing wasn't the end of their journey, it was only the beginning. The environment on Proxima Centauri B was harsh, to put it mildly. With no breathable atmosphere and constant radiation from the star's solar flares, survival depended on one thing: technology. The first colony had to be entirely self-sustaining. They couldn't rely on Earth for resupply. Everything they needed to survive, food, water, shelter, had to be produced right there, on a world that had never supported life. The first step was establishing the colony base, massive, dome-like structures capable of shielding the crew from the deadly radiation. Inside these domes, they set up the essentials: oxygen-generating systems, hydroponic farms for food, and water filtration systems. Everything had to be airtight, controlled, and perfect. A single mistake could mean disaster. But these pioneers weren't just focused on surviving. They were focused on changing the planet itself. The grand plan wasn't just to hide under domes forever. The long-term vision was to transform Proxima Centauri B into a place where humans could eventually walk outside without a suit, breathe the air, and live in the open. To achieve this, the crew deployed massive atmospheric processors, machines designed to kickstart the process of creating an atmosphere. These processors began the long, slow process of converting carbon dioxide and other gases from the planet's surface into something more breathable. It was a monumental task, and it was clear that this wouldn't happen overnight, or even in their lifetimes. The first settlers on Proxima Centauri B knew they were planting seeds for a future they might never see. The atmospheric processors were just the beginning. The initial phase of terraforming would take decades, even centuries, but they had taken the first step. And as they looked out at this strange, desolate world, they knew they were building something bigger than themselves. They were building a future, one small step for a human colony, but a giant leap for the survival of our species. The first few decades after landing on Proxima Centauri B were about survival, establishing the colony, protecting it from the harsh environment, and getting a foothold on the planet. But as the colony grew, the focus shifted from merely surviving to transforming the planet itself. The settlers knew that if Proxima B was ever going to become truly habitable, they needed an atmosphere. Not just any atmosphere, a breathable one, rich in oxygen, capable of supporting human life. The first step was tackling the atmosphere, or more accurately, the lack of one. Proxima Centauri B had no breathable air and no natural protective shield from the radiation of its parent star. To change that, the colonists initiated large-scale engineering projects aimed at releasing greenhouse gases into the atmosphere. These gases, trapped in the planet's soil and rocks, could be harvested and released using enormous atmospheric processors. But it wasn't without its challenges. Proxima Centauri B's star, Proxima Centauri, was a red dwarf, and like many red dwarfs, it was prone to violent solar flares. These flares sent intense bursts of radiation toward the planet, threatening any life or system exposed to it. Even with the atmospheric processors running at full capacity, the colonists still needed to figure out how to protect the planet's developing atmosphere from these unpredictable outbursts. To counteract the star's deadly flares, they installed protective magnetic field generators. These massive structures, inspired by Earth's natural magnetic field, were designed to deflect some of the radiation before it could strip away the atmosphere or reach the surface. It was an imperfect solution. After all, even Earth's magnetic field isn't a perfect shield, but it helped buy time. With the atmosphere slowly building up, it was time to address another critical component: water. Without it, there could be no life, no ecosystems, and no hope of making Proxima B habitable in the long term. The colonists faced a tough reality. Proxima Centauri B didn't have large reservoirs of liquid water like Earth. There was some ice trapped underground, but not nearly enough to sustain a growing colony or terraform an entire planet. So, the solution? Bring it from space. It sounds like something out of a sci-fi novel, but by the 22nd century, humanity had developed the technology to mine ice from asteroids and transport it to Proxima B. The colonists identified several icy bodies in nearby space, remnants of comets and asteroids, and sent automated ships to harvest them. These ships, using advanced propulsion and AI navigation, would attach themselves to the ice and tow massive chunks back to the planet. Once there, the ice was melted and released into shallow artificial lakes created on the surface. Over time, the planet began to change. The first trickles of water formed rivers filling the lakes. These lakes, though still small and isolated, marked the beginning of a new phase for Proxima B, one where water, the very essence of life, began to flow. Of course, water and air alone aren't enough to make a world truly habitable. The next phase involved life itself, introducing organisms that could help terraform the planet from the inside out. And this was where bioengineering came into play. The first organisms they introduced were hardy algae and microbes. These organisms were designed to survive in the planet's still thin atmosphere and cold temperatures. But their real purpose was to start producing oxygen, an essential element for human survival. These bioengineered species were tough, capable of withstanding the harsh radiation from the star and thriving in low-nutrient environments. The results were slow but promising. Over the years, the algae began to spread, photosynthesizing in the thin atmosphere, slowly releasing oxygen into the air. It wasn't a lot, not enough for humans to breathe freely yet, but it was a start. A sign that life, even in its simplest form, could survive and even thrive on Proxima B. Alongside the algae, bioengineers also developed more advanced microbial life, capable of breaking down minerals in the soil and releasing essential gases that could further alter the atmosphere. These microbes were the unsung heroes of the early terraforming efforts, working at a microscopic level to change the chemistry of the planet itself. It was a delicate balance. The colonists knew that while they could introduce life to the planet, they couldn't control everything. Terraforming was as much about guiding natural processes as it was about technological intervention. And in the early stages, there were still many unknowns. How would the planet's ecosystem evolve? Could the atmosphere stabilize before the next major solar flare? Still, with each year that passed, the planet changed bit by bit. The colonists kept working, knowing that they were laying the foundation for future generations. They understood that the results of their efforts wouldn't be fully realized in their lifetimes. Terraforming, after all, is a long game, a 200-year project that required patience, perseverance, and faith in the science they were pioneering. By the end of this phase, after 70 years of relentless effort, Proxima Centauri B was no longer the barren rock it had been when the first settlers arrived. The atmosphere, though still thin, was slowly becoming more stable. The lakes and rivers, though shallow and small, were a sign of what was to come. And the algae, quietly working away in those lakes, was the first sign of life taking root on an alien world. It was still a far cry from Earth, but the dream was alive. Proxima B was beginning to transform, slowly, methodically, but undeniably. And as the settlers looked out at the slowly changing world, they knew they were part of something bigger. A new chapter in human history where humanity wasn't just surviving, it was thriving, on a world light years away from the one they had once called home. By the turn of the 22nd century, Proxima Centauri B had reached a tipping point. The early decades of slow, painstaking work, carefully releasing greenhouse gases, introducing water, and cultivating primitive life forms, had begun to show real, tangible results. But what came next would redefine the planet's transformation. The terraforming process, once labor-intensive and gradual, began to accelerate at an unimaginable pace, powered by cutting-edge automation, AI-driven machines, and revolutionary bioengineering breakthroughs. Terraforming, once the domain of a few determined scientists and engineers, was now a planetary-scale project. Massive, automated systems reshaped the very landscape of Proxima Centauri B. AI-controlled machines carved out valleys, built towering mountain ranges, and dug vast basins for future oceans. These weren't just aesthetic changes, they were calculated modifications designed to regulate the planet's nascent climate. Mountains would act as natural barriers, guiding winds and trapping moisture, while valleys would collect water from the newly introduced rivers and lakes. And as the machines did their work, something miraculous happened. For the first time, rain began to fall on Proxima Centauri B. Imagine it, a planet that had never known rain, suddenly washed in it. The first storms, heavy and dramatic, swept across the newly formed valleys and plains. Rivers, once shallow and man-made, began to fill naturally. The rainwater gathered in great basins, forming massive oceans and interconnected waterways. For the first time, Proxima B was showing signs of an Earth-like water cycle, with rain, rivers, and eventually flowing into the oceans. These new bodies of water weren't just about aesthetics. Oceans and rivers are critical to regulating a planet's climate, storing heat, and distributing moisture. As more water was introduced, it catalyzed other atmospheric changes. The greenhouse gases that had once been released to trap heat now started to stabilize, and Proxima Centauri B began to settle into a more temperate, less volatile state. For the first time, it started to feel alive. But it wasn't all smooth sailing. Terraforming at such an enormous scale came with massive risks. With the planet's atmosphere and weather patterns still stabilizing, there were unintended side effects. Violent storms that swept across the colonies, sometimes for days. Torrential rains, high winds, and lightning strikes became common. In some regions, entire settlements were destroyed by floods, while others suffered droughts when the atmospheric systems malfunctioned. What the settlers had hoped would be a planet of calm and balance was often unpredictable and dangerous. There were times when it seemed the planet itself was fighting back against the terraforming process. Failed atmospheric regulation led to storms so violent they tore through early settlements. Crops were destroyed, water systems were overwhelmed, and colonists faced dwindling resources. They had come to Proxima Centauri B with the dream of building a new Earth, but for a time it felt like they were merely surviving the chaos they had inadvertently unleashed. But humanity persevered. Crisis after crisis, the settlers adapted. They learned to manage the unpredictable weather, building stronger, more flexible infrastructure. They developed advanced resource management systems, ensuring that food and water were evenly distributed, even during the toughest times. With every disaster, they grew more resilient. The terraforming boom was, at times, a trial by fire, but the colonists were determined to succeed. And gradually, through all the hardship, the planet stabilized. The storms, while still dangerous, became less frequent and more predictable. The atmospheric regulators, once prone to malfunction, were upgraded and fine-tuned. New settlements were built in safer areas, away from flood zones and extreme weather regions. And as the climate became more stable, something even more remarkable began to happen. Life took hold. With the atmosphere thickening and water flowing freely, the bioengineered organisms introduced decades earlier began to flourish. The hardy algae that had been seeded in the early lakes and rivers spread rapidly, oxygenating the water and enriching the soil. Scientists then introduced more complex plant life, bioengineered mosses and grasses that could withstand Proxima Centauri B's unique environment. These plants, designed to grow quickly and thrive in low-nutrient conditions, began to transform the barren landscapes into the first patches of greenery. It wasn't Earth, not yet, but the sight of green, those first tufts of grass, the spread of moss along the water's edge, was a powerful reminder of why they had come. The colonists weren't just building a new world, they were creating life on a planet that had once been a lifeless rock. And with each year that passed, that life spread further. The air became richer in oxygen, the water clearer, and the weather, while still unpredictable, grew more manageable. But even as the planet began to thrive, the challenges never truly went away. The process of terraforming is a delicate balance, and one misstep could send everything into chaos. There were still natural disasters to contend with. Earthquakes caused by the shifting of the artificially formed landscape. occasional flare-ups of deadly storms, and even the odd failure in the atmospheric processing systems. The colonists remained vigilant, knowing that while they had made incredible progress, Proxima Centauri B was still very much a work in progress. And yet, despite these obstacles, the colonists pressed on. By the end of the 23rd century, Proxima Centauri B was unrecognizable from the barren rock it had once been. The terraforming boom had reshaped the planet in ways no one could have imagined just a few generations earlier. Vast man-made oceans now covered nearly a third of the planet's surface, rivers wound their way through valleys and plains, and rainstorms, while still rare, were a natural part of the planet's evolving weather system. Proxima B was no longer just a distant exoplanet, it was becoming a new world in its own right. By this point, the colonists had done more than simply terraform a planet. They had built a foundation for future generations. The atmosphere was now breathable, though still thin in some regions. Water cycles had been established, and the first signs of a balanced climate were emerging. While it wasn't yet a place where humans could walk outside without protective gear, it was well on its way to becoming that. The transformation of Proxima Centauri B was no longer just a dream, it was a reality. The terraformers of Proxima Centauri B had succeeded where many thought they would fail. They had turned a barren alien world into a place where life could not only survive but thrive. And though there was still much work to be done, one thing was certain: the future of Proxima Centauri B was brighter than anyone could have imagined. The 200-year journey was well underway, and the dream of a new home for humanity was closer than ever before. By the mid-23rd century, the transformation of Proxima Centauri B had entered its final phase. The planet, once a barren, rocky wasteland, was now unrecognizable. The atmosphere was thicker, the climate more stable, and most remarkably of all, life had truly begun to take hold. The early seeds of bioengineered organisms and hardy algae had evolved into full-fledged ecosystems. What had once been a world hostile to all forms of life was now teeming with it. Forests of genetically modified trees and plants began to spread across Proxima B. These species, carefully engineered from Earth's flora, were designed to thrive in the planet's unique environment, using its still-developing atmosphere to grow and evolve. Some of these forests were unlike anything seen on Earth: massive, towering trees with bioluminescent leaves, and alien grasses that shimmered with vibrant colors in the pale light of Proxima's red dwarf star. This new, thriving plant life was crucial, not just for creating oxygen but for establishing the foundation of an entire ecosystem. With the forests and plant life spreading, the next step was to introduce animal life. Early settlers had brought with them genetically modified species from Earth, species that could form the basis of Proxima B's new biosphere. These animals were adapted to the planet's lower gravity, thinner atmosphere, and unique climate. The colonists knew that creating a balanced ecosystem required more than just plants. It needed herbivores to graze the fields, predators to keep populations in check, and pollinators to support the flowering alien flora. These weren't simply Earth animals placed on a new world. The animals of Proxima B were designed to thrive in this alien environment. Herbivores with denser muscles to handle the gravity difference, and predators with heightened senses to hunt in the planet's dim light. Even Earth's bees, modified to pollinate the new alien flora, adapted to the longer days and nights. Over time, these genetically modified species began to flourish. What started as careful bioengineering had evolved into a fully functional ecosystem, unlike anything ever seen on Earth. As life spread across Proxima Centauri B, so too did human civilization. What had started as a small, fragile colony of a few hundred settlers had grown into a vast, self-sustaining society. By the 24th century, the colony was no longer an outpost clinging to survival but a thriving network of cities with millions of inhabitants. These cities, built with futuristic technology and designed to work in harmony with the terraformed landscape, became symbols of human perseverance, ingenuity, and ambition. These cities were unlike anything on Earth. Built to complement the alien environment rather than dominate it, they utilized the planet's natural resources in ways that had never been done before. solar energy harvested from Proxima Centauri's constant, albeit faint, red light, wind power from the still frequent storms, water purification systems drawn from the planet's newly created rivers and oceans. And all of this without the need for the heavy environmental impact Earth's cities once had. As Proxima B's human population grew, so too did its culture. The settlers, separated by light years from Earth, began to develop their own distinct identity. Life on Proxima Centauri B was different, shaped by the planet's unique challenges and its alien beauty. Over the course of several generations, a new society emerged. The people of Proxima B became pioneers not just in the physical sense but in the cultural sense as well. Their culture was shaped by their surroundings, by the alien landscapes they called home, by the constant presence of the red dwarf star overhead, and by the very nature of terraforming itself. On Proxima B, time was experienced differently. The planet's days and nights, longer and more drawn out than on Earth, influenced everything from daily routines to architecture to art. The people here began to celebrate their relationship with their new world, creating art that reflected the strange, shifting beauty of the planet and building philosophies around their role as stewards of a once lifeless world. But with these new cultural practices came difficult questions. Questions that every generation on Proxima B would wrestle with. Was it right to change a planet so fundamentally for human needs? Proxima Centauri B, once a barren, untouched world, had been reshaped and re-engineered into something it was never meant to be. Had humanity, in its quest to survive and thrive, overstepped its bounds? And if they could terraform Proxima B, what was stopping them from doing the same to other worlds, even those with their own forms of life? On Earth, debates about environmental ethics had raged for centuries. Now, those same debates were happening light years away. Proxima B's inhabitants began to reflect on the nature of colonization, not just in terms of human expansion, but in terms of responsibility. Was it enough to create a new home for humanity, or did they have a duty to protect the untouched places in the universe, even if they were uninhabitable by human standards? Despite these questions, one thing remained certain. Humanity had done the impossible. They had transformed a distant, inhospitable planet into a world teeming with life, a world where forests grew, rivers flowed, and a new society thrived. The colonists of Proxima B weren't just survivors of the terraforming process, they were its caretakers, shaping a future that extended beyond themselves. And with the foundations of life firmly established, the question of what came next loomed large. Would humanity continue to terraform other worlds, or would they focus on deepening their connection to the one they had just created? The settlers of Proxima Centauri B had made history, but their story was only just beginning. As the planet continued to evolve and the ecosystem flourished, humanity faced its greatest challenge yet. What kind of future would they build on this new world? And how would the lessons of Proxima Centauri B shape the future of human civilization, not just on this planet, but throughout the cosmos? Could Proxima Centauri B be the first of many, or will it remain humanity's greatest experiment, the one that redefined what it means to call a planet home?